Okay, welcome back to the Maths channel. It's your teacher, Mr. Lim here. In this video, we're going to be looking at part 2 of the second lesson of the Year 12 Advanced Topic Motion and Rates. So we'll be looking at HSC questions or HSC style questions. So let's have a look at the first one. The displacement x meters from the origin at time t seconds of a particle traveling in a straight line is given by x is equal to t cubed minus 9t, where t is greater than or equal to 0. Okay, so we can tell here that this is the displacement because it's x, right? And it actually tells us displacement is x meters. And t has to be greater than or equal to 0 because we can't have negative time. So question A says, find the velocity at time t seconds. So because we're given displacement, in order to work out velocity, we need to differentiate with respect to time. Differentiate displacement. So we'll get 3t squared minus 9. Alright, question B. Calculate the velocity when t is equal to 2. So when t is equal to 2, we know that the velocity is equal to 3 times 2 squared minus 9. We're just going to sub that straight into here, because t is 2. So we get 3 times 4 minus 9, which is 3. So let's put this in, let's put the correct units. Because this is x meters in t seconds, velocity is going to be meters per second. Alright, question C. Find the time when a particle is stationary. So stationary means that it's not moving. That means velocity is equal to 0. So when velocity is 0, that means this whole thing is equal to 0. 0 will equal to 3t squared minus 9. So we'll move the 9 over. We'll divide by 3. And then we'll square root both sides. But remember, I know we usually write plus minus square root, but we cannot write that here because t has to be positive. It has to be greater than or equal to 0. So I'm going to write a concluding statement. Therefore, particle is stationary at root 3 seconds. Alright. This is the 2018 advanced paper, question 12D. So the displacement of a particle moving along the x-axis is given by x is equal to t cubed on 3 minus 2t squared plus 3t, where x is the displacement from the origin in meters, and t is the time in seconds, for t is greater than or equal to 0. So let's just highlight some stuff. X is displacement in meters, t is in seconds, alright, and it has to be positive. What is the initial velocity? Okay, initial velocity. Initial means when t is equal to 0, right? So, because we don't have velocity, we only have displacement, we need to differentiate. So when we differentiate our displacement function, we will get t squared minus 4t plus 3. So what is the initial velocity? When t is equal to 0, velocity is equal to 0 squared minus 4 times 0 plus 3, which is just 3 meters per second. Alright, part B, or part 2. At which times is a particle stationary? So we know it's stationary when velocity is 0. Okay, so stationary when v is equal to 0. It's not moving. So we make v equal to 0, and then we've got t squared minus 4t plus 3. And so what we need to do here is we need to factorize. So here we've got a mnemonic, so that factorizes to t minus 3, t minus 1 is equal to 0, and therefore t is equal to 1 and 3. So I'm just going to write concluding statement. Therefore, particle stationary at 1 second and 3 seconds. Alright, and part 3. Find the position of the particle when the acceleration is 0. So we need to work out acceleration. That means we need to differentiate velocity this time. So acceleration will equal to 2t minus 4. Okay, so we're differentiating this with respect to time. So when the acceleration is 0, we can see here that t is equal to 2. Okay? The question is, have we answered the question? The question says find the position of the particle. So that means find the displacement. Find the displacement. So we now need to substitute this value of t equals 2 into the original to work out the displacement. Okay, so when t is equal to 2, the displacement is equal to 2 cubed on 3 minus 2 lots of 3 squared plus 3 times 2. So right, that should be 2 lots of 2 squared. Okay, so 2 equals, alright, answer cubed on 3 minus 2 answer squared plus 3 answer is 2/3. Right, so therefore the particle is, because this is positive, it's 2/3 of a meter, because it's in meters, to the right of the origin. Right, why don't you pause the video, have a go with question 9 of the 2014 paper. Okay, so the graph shows the displacement x of a particle moving along a straight line as a function of time t. Which statement describes the motion of the particle at the point P? So at P, because here we can see that each of these options talk about velocity and acceleration. So it's important for us to remember that displacement is like, it's sort of like saying f of x is displacement. Velocity is like saying the first derivative. And acceleration is sort of like saying the second derivative. And what do we know about the first derivative? The first derivative talks about gradient. Okay? It talks about gradient. That's why it's also known as the gradient function. The second derivative talks about concavity. Okay, is it concave up or is it concave down? So at point P, if we were to draw a tangent at that point to the curve, the tangent will look something like that. Right? And because it's sloping down, that means the gradient has to be negative. Therefore, velocity has to be negative. And therefore, it's not C or D. Right. Now we need to think about concavity. At this point, is it concave up or is it concave down? Well, we can see here that somewhere around here is the point of inflection, right? Where the concavity changes from concave down to concave up. And point P is part of the concave up. Concave up means that the second derivative has to be positive. It has to be greater than 0. Therefore, acceleration, because that's the second derivative, has to be positive. And therefore, the answer is A. Alright, 2014. The displacement of a particle moving along the x-axis is given by x is equal to t minus 1 over 1 plus t, where x is the displacement from the origin in meters, t is the time in seconds, and t is greater than or equal to 0. Show that the acceleration of the particle is always negative, and what value does the velocity approach as t increases indefinitely? Why don't you pause the video and have a go with this one. Okay, so part 1, we want to show the acceleration we are only given displacement. So what we need to do is we need to differentiate twice. Okay, so part 1. We know x is equal to t minus 1 over 1 plus t. Well, I'm going to rewrite this so it's easier for me to differentiate. Okay, so I'm going to write it in index form, and so velocity, when we differentiate t, we'll get 1. When we differentiate this, we bring down the power, so minus 1 becomes positive. We write down what's in the brackets. We reduce the power by 1, and then we multiply by the derivative of what's in the brackets, which is just 1, so I'm just going to leave it as that. Therefore, acceleration, we can now differentiate this. The 1 will disappear because that's a constant. Bring down the minus 2. Write what's in the brackets. Reduce the power by 1. And then multiply by what's inside the derivative of what's inside the brackets, which is just 1. Okay, when we differentiate t, we just get 1. So now we can write this as minus 2 over 1 plus t cubed. Okay, positive 3 in the denominator. And so we can say that since t has to be greater than or equal to 0, well, that 1 plus t cubed will always be greater than 0. Okay? If that's always greater than 0, this is positive, then acceleration will be minus 2 divided by a positive number, which will be a negative answer. So we can say, therefore, acceleration will be negative for all t greater than or equal to 0. Okay? Alright, part 2. What value does the velocity approach as t increases indefinitely? Okay, so we're talking about velocity, so we're talking about this one here. So I'm just going to write that as 1 plus 1 over 1 plus t squared. Okay. So as t approaches infinity, we can see that the velocity will approach 1 plus 1 over 1 plus infinity squared. Well, 1 plus infinity squared is pretty much infinity. So it's going to approach 1 plus 1 over infinity. And 1 divided by anything really big will be really small. In fact, it will approach 0. So this will approach 1 plus 0, which is just 1. Now, remember, we're talking about velocity, so make sure you put in your units, meters per second. Okay, so that's what will happen to velocity as t increases indefinitely. Alright, pause the video, have a go with this one. A particle is moving in a straight line. Its displacement, x meters from the origin, O, at time t seconds where t is greater than or equal to 0, is given by x is equal to 1 minus 7 over t plus 4. Find the initial displacement of the particle. So initial displacement means when t is equal to 0, what is x? Well, we're already given x, so we can just write that. So when t is equal to 0, x is equal to 1 minus 7 over 0 plus 4. We can put that in our calculator. 1 minus 7 over 4 is negative 0.75. So I'm just going to write m there, put the units in, meters. Okay, so if you want to, you can write, therefore, particle is initially 0.75 meters to the left of the origin. Alright, part 2. Find the velocity of the particle as it passes through the origin. So we need to know when is the particle at the origin, and then we can work out the velocity. So origin is when x is 0. So I'm just going to move this fraction over to the other side. I'm going to multiply by the denominator to get rid of the fraction. And therefore, I can work out that t is equal to 3. Okay, so we can see here that the particle passes through the origin at t is equal to 3 seconds. So now that we've worked that out, we can actually work out velocity. But we don't have the velocity function, so what we need to do is we need to differentiate. So if we know that x is equal to 1 minus 7 lots of t plus 4 to the negative 1, then velocity has to equal to, well, when we differentiate at 1, that will disappear, that's a constant. Bring down the power, that becomes positive 7. Write down what's exactly in the brackets, reduce the power by 1, multiply by the derivative of what's in the brackets, which is just 1, okay, because the derivative of t is just 1. And so now we can say, when t is equal to 3, we can sub it into the velocity function. So when t is equal to 3, velocity is equal to 7 times 3 plus 4 to the power of negative 2. Three plus 4 is just 7, which is equal to 1/7. So the velocity is 1 over 7. Okay, make sure you put your units, meters per second. Okay, part 3. Show that the acceleration of the particle is always negative. Okay, so we've got the velocity function here. So to work out acceleration, we need to differentiate. So a is equal to, bring down the power, write down what's in the brackets, reduce the power by 1, and multiply by the derivative of what's in the brackets, which is just 1. And so I'm now going to write this as minus 14 over t plus 4 cubed. Now, the question tells us that t has to be greater than or equal to 0, right? We can't have negative time. So, as t is greater than or equal to 0, we can see that t plus 4 cubed, no matter what that is, will always be positive. Will be always greater than 0. Okay, it can't equal to 0. Therefore, a negative number divided by a positive number will equal to a negative number. So we can say, therefore, acceleration be negative for all t greater than or equal to 0. And last question. Sketch the graph of the displacement of the particle as a function of time. Part 4, okay. So we want displacement, okay, as a function of time. So here's my time. Here's my displacement. So I'm using x for displacement. All right. So because this is displacement, this 0 here means that this is the origin. So if it's down here, it's to the left of the origin. If it's up here, it's to the right of the origin. If it's over here, it is at the origin. Okay, at whatever t is equal to. So if that's t equals 7 seconds, then that's that. All right. So that's just to help you get an idea of that. Now, initially, we've already worked out that the particle is 0.75 meters to the left of the origin, right? We said displacement is negative 0.75. So I might write that in here, negative 0.75. So that's when t is equal to 0. Well, when is it at the origin? Okay. Part 2 says find the velocity of the particle as it passes through the origin. And so we worked out that it's at the origin when t is equal to 3. So at 3 seconds, so I'll just say that's 1, 2, 3. At 3 seconds, it's going to be through the origin. Okay, going through the origin. And we want to know, because basically we want to know what this graph is going to look like and whether it's going to approach a particular number. I might actually call this one 3. That might make it easier to see what's happening. Now, when we look at the original function here, we can see here that this fraction will never ever equal to 0. Okay, no matter what t is, positive or negative, 7 divided by any number will never equal to 0. The only way this can equal to 0 is if the top number was 0, because 0 divided by anything is 0. So if this will never be 0, then the displacement will never equal to 1 minus 0. It will never equal to 1. So that means we're going to have an asymptote at 1. Okay, and so we can now graph this. It's going to look something like this. Right? And that's pretty much it. Alright, so that's it for this lesson. I hope you found it helpful. We just went through some HSC questions, or HSC style questions, for lesson 2 of the motion and rates topic. If you liked this video, if you found it helpful, please give it a like. If you want more content like this, please subscribe, and I'll see you in the next video. Thanks.